Okay, today we're talking about Chapter 5, Section 4, Complex Fractions. Alright, nothing is ever good when we put the word complex in front of it, huh? I agree. So, a complex fraction is an expression containing one or more fractional expressions in the numerator, denominator, or both. So, for example, we see our examples. They're complex fractions. So if you recall in the last section, we basically had a problem like this, right? Where we had to get a common denominator. Well, we're going to do that today as well, except we're going to do it in the numerator and in the denominator. We're going to have to get a common denominator in the numerator and the denominator. Okay. There are two methods. Excuse me. There are two methods. So the first method. Hmm. Hey, we'll go back to the peanut butter and jelly sandwich thing because I think in terms of a student, or as a student rather, memorizing the steps isn't necessarily the thing to do, especially when you have just so much brain power to use for memorization, right? I know the feeling, even as an instructor, and there's only so much I really want to have on my plate. Anyways, let's proceed. So we've got 5x squared times y divided by, okay, now so this is just one of those problems where you can just kind of, as I mentioned in the last section, even my calculus students, when they see this problem, because they haven't seen a problem like this in so long, they're going to look at this and go, ugh, nope. But if you recall, it's the same thing as saying 5x squared divided by y, and let's put that little division symbol there, right? And now it becomes immensely easier. Immensely more easier? Let's just say easier. Let's just take the word immensely out. Now it becomes easier to solve, right? Because I can just change this to 5x squared over y times y squared over 10x. Right? And that makes it so much easier. So let's go ahead and do some canceling. So this y cancels with one of these y's. This 5 turns to a 1. This 10 turns to a 2. This x cancels with one of these x's. So I end up with what remains looks like just simply an xy in the numerator. And my denominator is just a 2. Right? And that's it. Now this is no bueno. Um, Again, this is saying by method one. Method two is multiply. So method one basically is you deal with each individual fraction independently. Method two is you get a common denominator of the entire fraction. Of course, we'll have examples of such, but I guess, and it really just depends on the problems. So some problems are easier to do doing one way, and some problems are easier to do doing the other way. So if you complicate things with saying, okay, method one here, method two here, I feel like you are going to ruin yourself. I think. I don't know. Let's proceed though. So looking at my numerator, okay, let's just deal with the numerator first. So I've got 1 over 4x minus, let's just put a space, let's do this. Let's do uh, the same structure I did in the last section. So we got 1, and then we put a little space between, and we do 3 over 2. Okay. All right, so looking for my least common denominator here, my numerator. Okay, so I have a 4 and a 2. What's the smallest number 4 and a 2 will go into? Well, 4 is already a 4, and 2 will go into 4, so that's good. So 4 is what I can go into. And then I have an x in one. I don't have an x in the other, but I can easily make an x in the other by multiplying by x, right? So my least common denominator here is just simply 4x. And now that I think about it, I don't need to have that big whole space there. So it's going to be minus 3 over 2. Well, in order to get this denominator to a 4x, I need to multiply by a 2x in the denominator and a 2x in the numerator. Okay, and by doing that, I end up with 1 over 4x minus 6x over 4x. And then now that I have a common denominator, I can say 1 minus 6x all over 4x. Okay, so that is now my numerator. Okay, so this is my numerator. We'll put it in there for numerator. Now let's simplify my denominator. Okay, so let's do my denominator. Least common denominator of my denominator. So I've got a 3 minus 1 over 2x. Okay, so how do I get, well, let's do it this way. Now you don't have to do it this way. It's just I'm doing it this way to really drive the point home. Okay, so I have a 1. That's redundant, but I'm gonna put it there anyways. Okay, so 1 and then a 2x. So my least common denominator here is just simply going to be 2x. So I need to multiply this fraction by 2x over 2x. And I don't have to deal with the fraction on, I don't have to deal with this fraction at all because it already has the least common denominator. So by doing this, I've got a 3 times 2x, which is 6x, 6x over 1 minus 1, I'm sorry, I didn't mean to say over 1, over 2x minus 1 over 2x. Well, I got that common denominator that I'm looking for, so this ends up being a 6x minus 1 over 2x. Okay, and this is my denominator. So let's go on a new page and see if I can. This is gonna suck. Okay, so 1 minus 6x over 4x. 1 minus 6x over 4x. So 1 minus 6x over 4x, and it's divided by 6x minus 1 over 2x. Minus 1 over 2x. And of course, I know I can change that division symbol to a multiplication symbol. So I say 1 minus 6, ooh, that's a horrible 6. 1 minus 6x over 4x multiplied by 2x over 6x minus 1. Okay. Now, we know that we can cancel this and this, right? They're not the exact same, but they are the negatives of one another, right? So it's going to turn into a negative 1, right? 1 is a positive 1, one's a negative 1, one's a positive 6x, one's a negative 6x. So they do cancel, but they cancel to make a negative 1, not a 1. All right, this x cancels with this x, and this 2 cancels with this 4, makes a 2. So my solution here is just going to be a negative 1/2. All right, now we get to method 2, and like I said, your methods are really going to vary depending on what your what we'll do, put that in there, depending on what your problem is. In this particular problem, it's pretty easy to see what a common denominator of the entire problem is going to be. Yeah, let's actually do it this way. I was going to snip that, but instead, what we're going to do is we're going to look for, and again, this is looking at my steps here. It says multiply the numerator and denominator of the complex fraction by the least common denominator of all individual fractions. So what we're doing here is looking at, we have x squared, and we have x. Okay, so what we're going to do is we're going to multiply the entire problem by the least common denominator of all the fractions. Now, well, yeah. So my least common denominator, as I said, was x squared. So I have an x squared. I'm going to multiply the numerator by x squared. And I'm going to multiply the denominator by x squared. Okay. So actually, let's put it, we'll keep it blue for right now. Kind of stay consistent with what I have been doing. So I've got 4 minus 6 over x and 2 over x minus 3 over x squared. So let's go back to this example here. If I were to have multiplied this entire problem by the least common denominator of the numerator and denominator, I'm looking at, actually this one isn't horrible, 4x, 2, and 2x, right? So I could have multiplied the entire problem by a 4x, right? Because 4x obviously goes into 4x. 2, I multiply by 2x to get to 4x. And obviously 3 is whatever, I can multiply that by whatever. And then 1 over 2x, you can't really see because there's stuff over there. But I can multiply that by a 2 to get to 4x as well. So it actually isn't so bad. And honestly, this would be my preferred method as opposed to doing things individually. But anyways, what we're going to do here is we're just going to distribute. Okay, and by distributing, well, what is x squared times? What is x squared times 4? Well, that's just going to be 4x squared minus, well, 6x squared over x is just going to be 6x. And then x squared times 2 over x, that's going to be 2x squared over x, which is just going to be 2x. And then minus 3. Right? And then from here, we can looks like the numerator can be factored, so that's good. So we're going to factor out, it looks like a 2x. So I've got a 2x minus 3, and of course we see where we're going here. They cancel, so my solution here is just simply 2x. Yeah, the rest, I mean, we're going to do them, but the rest are method 2. And like I said, method 2 is my preferred way to go about things. But you can do whatever you want. They both work. Okay. So let's go ahead and rewrite this because we have negative exponents. So let's write this with positive exponents before we do anything. Okay. So x to the negative 1 is 1 over x minus x to the negative 2, which is going to be 1 over x squared all over 1 plus, and they have 2 times x to the negative 1. Okay, that negative exponent is only attached to the x, not the 2. So we're going to say the 2 remains in the numerator, and then the x squared goes in the denominator. And let's do some scaling here. And then minus, and again a 3, the negative exponent is only attached to the x, so we're going to say minus a 3 over x. I got a little ahead of myself. That's supposed to just be x to the first power there. Okay. All right, so hopefully it's abundantly obvious what I need to multiply this entire problem by. So it looks like I need to multiply it by x squared over x squared. Okay, and again, I put it on the back this time. It doesn't really matter, front or back, doesn't matter. The thing is, I'm going to distribute through, well, there's 3 of them down here. Okay, so we're going to distribute through in each of them. Okay, and actually, let's go ahead and get rid of those arrows because I think that can get a little messy there. So if I do this, so x squared times 1 over x, well, x squared over x is going to be simply an x minus, and then it's going to be x squared over x squared, which is 1, so it's going to be minus 1. So that's my my numerator there. My denominator, just distribute the x squared into the 1 there. Well, that's just going to be x squared. Distribute it here. 2x squared over x is going to be 2x plus 2x. And then minus 3, because 3x squared over x squared. And then from here, it looks like we're going to factor. So we're going to have x minus 1 in my numerator. My denominator is x squared plus 2x minus 3. It looks like it can be a plus 3 minus 1. So x plus 3, x minus 1. My x minus 1's cancel. So I'm left with, there's a 1 up there, x plus 3. Okay. And that is that problem. And then the last problem for this section. Oh, this looks horrible. Oh no. Okay, this is a multi-pager. This is not good. It could be alright. Who knows? I know. It's not going to be good. Okay. So, we're going to, let's go ahead and, we don't necessarily have to rewrite this because we can see that this last denominator is indeed a difference of squares, but we will write it out just for the sake of really driving the point home. So this is going to be a multi-pager, so be prepared. If you have to take a bathroom break or something, now is the time. Or you can just pause it. Okay, so W plus 3 and W minus 3. Let's fix that W up. There we go. Alrighty, so looking at this denominator, this denominator, this denominator, and this denominator, what is my least common denominator? Well, it appears it's going to be W plus 3, W minus 3, right? Because that's what appears, that those are the factors that appear, and they're all only to the first power. So let's do this. Let's move this over to the right here, because I also like to just put what I'm multiplying by over here to the left. So W plus 3, W minus 3. We're running so much out of room. Let's try this again. Let's move it just a tad more to the right. We're going to bump right into the problem. There. Okay, so let's try that. So my numerator, W plus 3, W minus 3. All right, and that's going to be multiplied by this whole problem here. W plus 3, W minus 3. Okay. Whew. Well, let's begin the factoring, or not factoring, let's begin the distributing process. So let's put this in yellow this time. So we're going to multiply this numerator by this term. Well, the W plus 3's cancel, so it's just going to be W minus 3. So we're going to have a W minus 3. We're going to multiply this all by this over here. Well, so the W minus 3's cancel this time, so we're going to have a W plus 3. So it's going to be a minus, and then again, we've talked about this before, make sure that you put your parentheses there. So it said W minus 3 is canceled, so W plus 3. And then that's that. And then in my denominator, it looks like I'm going to multiply this by 1. Well, that's just going to be this, right? It's going to be W plus 3, W minus 3. So W plus 3, W minus 3. And then I'll multiply this all by this fraction over here. Well, everything just cancels and I'm left with a 9. So that's good. So plus 9. Okay. And let's go and get rid of those parentheses here. So W minus 3, and then we have a minus W and a minus 3 all over. Well, W plus 3, W minus 3, again, that's a difference of squares. So it's going to be W squared minus 9 and then plus 9. Okay, so this problem actually isn't terrible, I guess. So looks like this W and this minus W cancel. This negative 9, this plus 9 cancel. So we are left with a negative 3 minus 3, which is a negative 6 over w squared. Okay, and that, how in the world did that take up so much? I mean, I did all that. Huh. I don't know. I mean, I showed the multiplication there. I don't know why that took so long for them as opposed to me. I don't know. I don't feel like figuring it out either. Oh well. That concludes Chapter 5, Section 4.